Have you ever wondered why some playground slides feel like a high-speed drop, while others are slow and steady? The difference is the shape of the slide. Trace down the ladder, across the ground, and up the slide to see a perfect right-angled triangle. We start measuring right here, where the slide meets the dirt. We call this corner home base, our anchor point. To understand how this triangle works, we only need to identify the three different sides. First, let's look at the part you actually sit on, the long, slanted surface of the slide. This is the longest side of the triangle, and it's called the hypotenuse. The hypotenuse is a constant. No matter how we change the triangle, this slanted side stays the longest one. Remembering this one name gives us the first piece of the triangle's layout. Now let's go back to our home base at the bottom of the slide to find the other two sides. Looking straight across the triangle from home base, you'll find the ladder. Because it's across from us, we call this the opposite side. Then there's the ground. Since it's right next to home base, we call it the adjacent side. These names, opposite and adjacent, simply describe where the sides are located in relation to where we are standing at home base. Now that the sides have names, we can use a rule from Pythagoras to see how their lengths work together. The adjacent side, along the ground, measures 4 units long. The opposite side, our ladder, measures 3 units high. Meeting at a right angle, sides of 3 and 4 make the hypotenuse exactly 5. This 3-4-5 relationship is a standard for our calculations. Now that we have our names and our numbers, we can use a simple shorthand to link them all together. This shorthand is SOHCAHTOA. It's a helpful way to remember how the sides of our triangle relate to one another. So, HOH is for sine, the opposite side divided by the hypotenuse, which is 3/5. Next, CAH for cosine, the adjacent side divided by the hypotenuse, or 4/5. Finally, TOA for tangent, opposite over adjacent, giving us 3/4. These three ratios are the core functions of trigonometry. They are simply different ways of looking at the relationship between the sides of a triangle. While we used a slide today, these triangles are built into the structures all around us. Skateboard ramps, staircases, and even wheelchair ramps use these exact ratios to ensure the slope is at the right angle for people to use them. Even a tree casting a shadow on a sunny day creates an invisible right-angled triangle that follows these same rules. By identifying the triangle's parts, using the SOHCAHTOA shorthand, you decode the physical world. Next time, we'll look at even more ways to use these functions to solve problems.